Have you ever noticed that if you take the derivative of the formula for the area of a circle with respect to the radius, you get the formula for the circumference of the circle? A question for you. If I have a square of side length x, the area is x squared. And if I take the derivative of that, I get 2x. However, the perimeter of the square is 4x. Many people realized in the comments to that video that it doesn't work for a square because when you increase the side length x on a square, what happens is that the area is growing on two of the sides of the square and not all around the square. So it makes sense in this case that the instantaneous rate of change of the area with respect to x is just 2x in this case and not the entire perimeter. Now, you have to be very careful estimating the instantaneous rate of change in terms of these pictures because sometimes you don't get exactly the right answer. For example, suppose now that we are computing areas of the squares in terms of the semi-diagonal. So now x is the distance from the center to one of the vertices of the square. It would seem in this case that yes, the instantaneous rate of change of the area with respect to x, with respect to the semi-diagonal, should be the entire perimeter of the square, right? So is that equal? Is the derivative of the area equal to the perimeter? Using Pythagoras' theorem, we can compute the area of the square with respect to x, and the area should be 2x squared. And similarly, again, using Pythagoras, we can compute the perimeter to be 8 times y, so it's 4 square root of 2 times x. And so the derivative of the area is 4x, but the perimeter is 4 times the square root of 2 times x. So what is going on here? Why are they off by a factor of the square root of 2?